Algebra 1, Notes 5.3, Slope-Intercept Form. Slope-intercept form is probably the most common way that linear equations are written. The nice thing about slope-intercept is the name tells you exactly what you need to know. You need to know a slope, or the slope, I should say, and an intercept. In this case, it's the y-intercept. So slope-intercept form is always written as y equals mx plus b, where m represents the slope and b represents the y-intercept. We're going to use this throughout the lesson today. It's something you definitely need to learn. So for an example, we have y equals negative 3x plus 17. You can see that the slope is negative 3. That's your coefficient in front of x, the m term. And the y-intercept would be 17. That's the b value at the end of the equation. Now, remember, the y-intercept means where does the graph cross the y-axis. So the point 0 and 17 is what the y-intercept of 17 represents. Okay, one more thing, I skipped over it, but it says over here to the left, think about it. Why would slope-intercept form not work for vertical lines? If you look just below this video, there's a form for you to answer that question. I want to hear your thoughts about that topic. Why would vertical lines not work with slope-intercept form? All right, let's do a little practice. Number one, find the slope and the y-intercept for the graph y equals 2x minus 5. Now remember, we're in the form y equals mx plus b. So what I know is that the slope is equal to 2 and the y-intercept is negative 5. Now if you want to write out the word slope and y-intercept instead of using the abbreviations of m and b, that's fine. That's your preference. I'm also fine with you just writing the shortcut abbreviations as long as you know what they stand for. All right, number two is go in the opposite direction. Write the equation for the line that has a slope of negative 1/2 and a y-intercept at 4. So we know the slope again is negative 1/2. Y-intercept is 4, so we could just simply plug it in. Y equals negative 1/2 x plus 4. That's it. That's all there is to it. All right, pause the video and do 3 and 4 on your own. Okay, now you can compare your answers to mine. Hopefully you got the same results. If not, take a look at mine and see where you went wrong. Onward. All right, find the equation in slope-intercept form of the graphed line. Apologies for my cracking voice. In order to find the slope-intercept form of a line, we really, again, only need to know two things, the slope and the y-intercept. So when I look at this line right here, I could see this point right here, 0, negative 2, is key to this because it tells me the y-intercept is negative 2. Now, what I need to do is find another place on the line that's an integer value. In other words, it goes through right through one of the intersections. And I can actually approach this a couple ways. One is just to count spaces. This is 1, 2, and 3. And this is 1. And they're both in the positive direction. So I know my slope is 3. Remember, slope is the rise over the run, or the change in y divided by the change in x. So this is positive 3, which then gives us an equation of y equals 3x minus 2. Once you find those two pieces of information, the slope and the y-intercept, these are a breeze. All right, same instructions on this one. I've got a couple of points marked for you, but they're not labeled. This one is 0 and 1. And again, that's a key point because it is the y-intercept, so we know that the y-intercept is 1. And then we can count. So I've gone down 1, 2, 3, 4. I'm going to write that as a negative 4. Even though distances are always positive, it's okay to go ahead and write a negative since we're moving down. But this, we're moving to the right, that's the positive direction, and its length is 3. So I know that the slope is the rise, which would be a downward change of 4, so negative 4, divided by the run to the right, 3. So negative 4/3 is the slope, so we'd know y is negative 4/3 x plus 1. I think you're getting the hang of this. All right, why don't you pause the video and do number 7 on your own. Okay, on number 7, I found the y-intercept to be positive 5, the slope to be negative 2. So that gives us an equation of y equals negative 2x plus 5. Okay, on 8 through 10, these are actually somewhat similar to the graph. The difference is we're just given 2 points. This will take a little bit of extra work because we have to find, again, the 2 pieces of information. So let's start on number 8. We need to find the slope and then the y-intercept. I'll start with the slope. And as you know, slope is the change in y. I'm going to go 7 minus 5 divided by the change in x, 3 minus 0, which is 2/3. Now, the y-intercept in this particular problem, if you're thinking about it, is actually given to us. The y-intercept is the point 0 and 5. We know that's a y-intercept because the x value is 0. And so we can go straight to the equation y equals 2/3 x plus 5. Okay, number 9 is going to require just a little bit more work. We do the same things as far as what we need to find. So we'll start with finding the slope. M is negative 3 minus 3 divided by 2 minus negative 1. That gives us negative 6 over 3, or just simply negative 2. The challenge on this one is, how do we find that y-intercept? There are a few ways you could approach it. One way would be you could graph this and see where it physically crosses the y-axis. However, it's not always integer values. Typically, we would avoid that. Just there's too many chances to make mistakes. So instead, what we do is this. We know the slope is negative 2. If you think about the form y equals mx plus b, x and y just represent an ordered pair that the line's going through. So what I'm going to do is pick negative 1 and 3 is my point x comma y. So I'm going to replace what I know. I know y is 3. M, that's our slope, remember. We already know that. That's negative 2. X is the x term on this first ordered pair. And then plus b. And our b value is our unknown. So what we need to do at this point is go ahead and solve for b. Just takes a little multiplication. Negative 2 times negative 1 is 2 plus b. Then we can subtract 2 from each side. We'll know b is 1. So our equation, y equals negative 2x plus 1. It's worth noting on this problem that we could have actually chosen the other point, 2, negative 3, instead of negative 1, 3. If you wanted to do that, you could. You would get the exact same values. It's kind of a cool thing about this. All right, why don't you give it a shot on number 10? And so pause the video, and when you're finished with it, hit play and compare your work to mine. Okay, welcome back. You can see my work for number 10 in front of you. You'll notice for demonstration purposes here, I went ahead and showed you first if you use the point 4, negative 5 to plug in, and then in green I used the point 15, negative 27. I mentioned this earlier, but it's worth repeating. It doesn't matter which point you choose. Either of the points will give you the same y-intercept. So either way, you get y equals negative 2x plus 3. All right. Last topic we're going to look at today is graphing these equations. This is strangely a really similar process to what we were doing earlier when we were picking out slopes. Like here we know the slope is negative 3/2 and the y-intercept is 2. Now if I want to graph that, I always start by plotting the b value, which is 2. That means it crosses the y-axis at positive 2. The next thing I do is apply that slope. The slope is negative 3/2, so that means I'm going down 3 and right 2. Or you could think of it as I'm going up 3 and left 2. Either way, we get the same line. And all I have left to do from here is to go ahead and connect. So our line will look something like this. All right, let's take a look at the next one. And I'm just going to graph it on the same plane. There's plenty of space there. Y equals 5x. Now notice there's something missing right out here. If you need to write it out, you can. It's a plus 0. That helps us to know, well, first of all, the slope is 5, but that plus 0 represents the y-intercept. Now what does that mean when we have a y-intercept of 0? That means it goes right through the origin, 0 and 0. So again, start by plotting that y-intercept, then apply the slope. 1, 2, 3, 4, 5, and over 1. You could do it again if you wanted to, up 5 over 1, or you could have gone the other way and gone down 5 and left 1, and you'd get the same result. And since lines are infinite, it is a good idea to go ahead and put arrows at the end. It's not something I'm super picky about, but it is best to include them. All right, so that is in blue, the graph for number 11, and then in red, the graph for number 12. Let's look at the last problem. I want you guys to do this on your own, so go ahead and pause the video, find that slope and y-intercept, graph it, and then hit play to see if everything looks good. Okay, you can now see what I've done on this last question. The slope is 1/2. The y-intercept is -4. So again, start graphing by plotting that y-intercept. Then apply the slope of up 1, right 2. Or again, you could think of it as down 1, left 2. It has the same effect. Now, the last job for you, I mentioned it earlier, but just below, for those of you visual, I'm drawing an arrow, but just below this video, there's a form for you to fill out. It's very brief. It does require just a little bit of thinking, but I want you to answer the question that's there and then come to class ready to work. Have a good day.